timing, I think, is really good here. So please try example number 5. Hello. Are you visiting us today? Mr. Anderson, nice to meet you. Are you with Aiden today? Fantastic.
Nice to meet you. I'm Ahmad. I'm Jack. This is like Aiden's in a class with a bunch of seniors, so.
I'm a freshman.
You're a freshman?
Yeah, he's a freshman. He's going to be a freshman next year.
I'm actually an eighth.
Wait, is that a joke? Wait. You're a freshman?
No.
I was like, wait, have you been lying to me for the past 2 months? Let's do it. Let's return to 5.
Hey, seniors, you're all going to be freshmen next year. So, the cycle starts all over again.
I can actually go to college right now.
So, wait, so that means that I can.
Bottom of the totem pole all over again.
Dude, we're voting in next
Or in
year's
Aiden's
election.
case, top of the
That's
totem
true.
pole.
I'm stressed out.
Okay, we're working on number 5. Number 5 is fairly simplified on some of the details, but it's not simplified on the concept. So please, check it out. It incorporates lots of loveliness for you all.
Oh, yeah. Okay. So,
Bobby, right?
Yeah.
What math are you doing right now? Geometry. Are you 8th grade? Okay, so you're a little more on the advanced track of things. Very cool. That's probably what you did in 8th grade, right? Geometry?
I did algebra.
But it gives you.
And
It gives you.
Very cool. What school do you go to right now? Slavey?
Yeah.
Have any questions about our math program or school questions or anything?
I mean, I went last year to the
Okay.
open house, and then I know the art director here, so I've gotten this last year.
But do you have any like nitty gritty detailed questions, things you haven't
I mean, I
learned
think
yet?
it's talk about math, but I don't really remember what the
So yeah, so for you, you're doing geometry right now. We'll give you a placement test. Assuming that went well, you'd probably come in at like the Algebra 2, Honors Algebra 2 level. The next logical course then would be like a DC Pre-Calc or a Pre-Calculus class. And then you'd been to either AP Calc AB or AP Calc BC or AP Prob and Stats. And then we go up to Calc 3 here. And so kind of depending on, if you can go straight from DC Pre-Calc to this course, which is Calc BC, or you can go to AB and then BC, or you could do Calc AB and then AP Prob and Stats or something like that. So you start to get a lot of options starting your junior year in your case. So, yeah. Does that make sense?
Yeah.
Okay. Very cool. Meg, welcome back.
I think I got it.
How'd it go?
I think it's.
It was good. It was a lot. It was really stressful, but it was fun.
Was the competition easier or harder or what you thought it would be?
I don't know what I thought it would be. I've played against most of the people before.
Okay.
Yeah. It was just,
We're glad you're back.
yeah.
Couldn't tell us what. Okay. Say, Logan's got something going on there. Jack is partway started / done. Aiden's feeling like he's got something going on there.
I'm 16, so.
Saki's got something.
I wasn't the limit.
Do the thing with the stuff? Yeah.
I'm just going. I think it's actually.
Oh, wait, I get it.
I do think it's negative 13, Bobby.
You got?
Yeah.
Oh, gold.
I lost my notebook.
Plays golf and jams goldfish in his mouth.
I think I left it in the library.
Yeah.
Goldfish, they never get old.
I also go to a lot of concerts, and that's pretty much my life. I play a lot of music.
I've been to a couple of Switchfoot concerts.
Dude, they're really good.
They are very good. Yeah, live, they're very good.
I've seen the Red Rocks and the Fillmore. And Elitch's.
Mr. Anderson,
Elitch's.
how long can I go to the library to do my notebooks?
What do you need your notebook for right now?
I have my notes from
From yesterday.
yesterday. No, not yesterday, from Monday.
Oh, like as applies to this?
Yeah.
Okay, you better go fast. I'm gonna do this one right now. Hey, Can anybody explain what makes this integral an improper integral?
I got it.
Goes infinity.
Yeah.
Goes
You
infinity.
don't know. You didn't.
You got this. You got this limit up here that you're going from 1 to infinity. Makes it improper. What's improper about that is a definite integral needs to have real numbers for limits. And it can't have any discontinuities. This has the infinity for a limit. So the way we handle this is we would write limit as b heads towards infinity of the integral from 1 to b of f prime of x dx. And once you have that set up with a limit, we've now kind of worked our way around this whole requirement that the limits of a definite integral be real numbers. And we're using a limit to help us get around that requirement. Did anybody recognize FTC 2 and 1 nicely incorporated into this? FTC 2 says that the antiderivative undoes the derivative. And then FTC 1, if you want to split it into the two parts like your book does, we find the difference between the two evaluations. So it would be the limit as b heads towards infinity, and it would be of f of x evaluated from 1 to b. So at this point, we've done FTC 2, and at this point, now we've done FTC 1. Right, so we've completed the full fundamental theorem of calculus at this point, and we can now apply the limit to both parts. If you guys remember, the limit of a difference means that you could just apply that limit to each of the pieces of the difference. So it would be the limit as b approaches infinity of f of b minus the limit as b approaches infinity of f of 1. Well, we already know that f of 1 is just 5. So the limit as b approaches infinity has no effect on that, right? Because it doesn't even have a b in there. So we'd put minus 5. And then the limit as b approaches infinity of it. Oh my gosh, it's up there in the given part, isn't it? It's in the question stem. It's right here. So we can say that that's negative 8. And we add those two together, we get negative 13. What do you think? So can anybody just like off the top of their head describe what the graph of f prime might look like given that answer?
It's like, I don't know what's going on over there. But from
Yep.
1 on, it's like, oh no, this one. It's like that.
It's got to be below the x-axis predominantly, right? Yeah, for sure. And, yeah, starting at 1, below the x-axis, no doubt. It could have some little blips above, but certainly below. Makes sense. Okay. So today, we're going to go through a few more examples. Today is basically just a reinforcement of what we covered before. So you're just going to get a lot of different looks at what improper integrals might look like. So we'll just practice these as we go along. Some of these will say that the calculator is active, others maybe not. And this will also bring in some other skills we've been working on. I do have to say, I always leave this one in here because it's a nice question. We're not going to do example 6 yet because we have not talked yet about for everybody how to find the volume of a solid based on cross sections. That'll come in a few units.
Let's not do cross sections.
Very excited. Can't wait to come back there.
Wishful thinking, Samuel, is so unproductive. Okay, but we will most certainly do example number 7. Example number 7. So if you would, maybe use your calculator to get a look at what the graph of the integrand looks like. That might help. And then see if you can set some stuff up to get you in a good place. And I don't know, we'll see how it all goes. Ready to go. Having looked at this graph now, do you all understand why this is an improper integral? Because at first it really doesn't look like one because there's a 2 and a 4 for the limits. I guess your first hint would be the fact that you've got a rational expression in there where your denominator has a clear 0. That could cause a vertical asymptote, potentially a hole or a removable discontinuity, but in this case it's a vertical asymptote. So did you guys split this up into 2 separate integrals? That's really what you got to do, right? So this would be a good first step to write the limit as, I don't know, maybe you split it up first. Maybe you go integral from 2 to 3 of 1 over x minus 3 to the 2/3 dx plus the integral from 3 to 4. Something like that. That would be fine. But then at some point you're going to have to apply the limit. And I'll get kind of technical here and encourage you to consider doing the same. I would say for this first one, let's see here, from 2 to 3. So this would be the limit as b approaches 3 from the left of the integral from 2 to b. And I will flip up here, x minus 3 to the negative 2/3, plus the limit as b approaches 3 from the right of the integral from b to 4. Like last time, some folks got a little concerned and said, hey, are we going to have the right and the left correct? And again, I think if you think about the logic behind it, I don't think that it's terribly, impossible for you. I don't think that that's something that I think would be worth, docking you a point for or something like that. But do encourage you to be accurate. Good math is just good math. So that's what I'm trying to show you, good math here. Okay, so I come over here and I start trying to actually compute this. I get the limit as b approaches 3 from the left. And thankfully, Timmy didn't mess anything up here. So we just need to do a straight up power rule, essentially. So did you all get 3 times x minus 3 to the 1/3 evaluated from 2 to b? Is that good? And on the other one, we'd have plus. The limit as b approaches 3 from the right of the exact same thing, except evaluated from b to 4. Okay, so now we're going to apply that FTC there. So it's going to be 3 times b minus 3 to the 1/3 minus, and then 2 minus 3 is negative 1. What's negative 1 to the 1/3? So it's going to be negative 1 times negative 3, essentially, right? So plus 3. I'm doing a lot of that detailed arithmetic in my head. Plus, this other one's going to look pretty similar. So it's going to be 3 times, it's going to be 1 to the 1/3, so that's just 1, minus 3 times b minus 3 to the 1/3. So how does this thing end up kind of finishing out? 3 plus 3, right? As you apply that limit, you get 3 minus 3 is 0 in both cases. So you get 0 plus 3 plus 3 minus 0. You do end up with a final answer of 6. So I want to come all the way back around. Santi had a question a long way at the start. He said, what's to prevent me from basically ignoring the asymptote in the middle, the 3, and just doing a flip up and plugging in the 4 and plugging in the 2 and hopefully getting a 6 in those cases. To me, that's what an uneducated calculus student would do. And I know that he... No, listen, you're taking that all the wrong way. He just asked the question, what would stop me from doing that? He didn't actually do it, right? So it was actually a pretty wise question because he saw, well, somebody maybe could do this. What would stop them? What would stop me from doing that? It would be somebody that thinks you can just apply a definite integral to whatever you want. So educated enough, but slightly uneducated, right? And so I would encourage you to think about, is this really an improper integral? And he even brought up would we be expected to see that there's a vertical asymptote there at 3? I would hope that you would, but I think I'd probably supply you with some kind of a graph or some sort of hint about, you probably ought to check for vertical asymptotes or something like that in a case like this, just to kind of help drive you towards the right place. So you've got to have limits here. If you avoid the limits entirely, you're going to have issues as far as like acknowledging what a definite integral actually can and cannot do. Okay. Does anybody else have a question? It's another one of those curious things, right? I mean, think about what we're doing here. And this might be interesting for Bobby to think about. So Bobby, what we're basically looking at is we are setting an interval up on this graph from 2 to 4. And we are partitioning this off. And we're essentially trying to find this red area. And totally ignoring the fact that the upper part of the area is formed by a curve, which is a whole other issue, right? it's interesting that wouldn't you think that some of the area would like spill out? Or there would be an infinite amount of area or something like that. Again, it comes down to how quickly are these parts of the graph approaching that vertical asymptote? Are they approaching fast enough? Or is it a little bit too slow? That's really what it comes down to. And the fact that this is a 2/3 right here, that's really what makes all the difference. So we'll get into those details as we delve into power series and as we kind of, work on this still a little bit more. But anyhow, other questions? Bobby, you basically have calculus mastered now, don't you? Yeah, totally. Okay, cool. All right, so why don't you guys look at number 8. I am a big fan of number 8 because number 8 is going to force you to use lots of skills. It's a lovely question, my friends. You're not going to get away with just like having your brain in neutral. It's Denver, right?
It's a small school.
Where'd you go?
Chicken McBuckets?
I've heard of that.
Score.
So we got vertical.
Not bad.
You play tennis?
For a golf bad for a golf player.
Not really.
Every soccer player will make at least one golf comment to me in their lifetime.
Roll across.
Yeah,
Oh, at least it's
There,
one
there,
sport.
sure. Actually, test is not mature. Which like aims out for people.
Alright,
You know, like
so
what
what's
they saw, right? Literally more.
So I just threw a first step up there that might be useful.
Oh my god. I'm sorry for everything that I said.
One equals a times x plus
One more room.
I am so good at this.
You're also super humble.
I'm the humblest person I know.
I'm literally the most humble person you'll ever meet. Never met anybody more humble than I am. Not even close, seriously.
Like, that's great, kid. The humility, like, it's all
Rolling the
my
trans-
veins.
or the
He's
shadow.
not even a transfer.
Just shadows. Yeah, he's not even invalid. What grade are you in?
I remember when I had shadows.
Oh, okay.
I remember when I was a child, I shadowed somebody's biology class, and it was really fun.
I
I
shadowed this
shadowed
class
someone's
straight.
I shadowed Luke McCaffrey.
You shadowed in my class?
Did you actually?
I swear to God, Luke McCaffrey.
Was that A, B, or BC?
It was BC.
He was
No, it
a-
was A.
My shadow ambassador was a cheerleader.
And I was like,
The
I'm never
craziest thing about it too was that Luke
I don't.
Now you're actually really good at
in
it.
class, and I got to watch Luke.
Not just here you are, but you actually know what you're doing.
Not right now.
Well, that's just because you were gone for a whole week.
Kid, though.
Yeah.
Prior to that, you were doing pretty good.
Alright, so let's see.
True.
Limit.
Very true.
Infinity.
Wait a second, is that 0? Wait, what's infinity minus infinity?
Oh, does that come up in this one?
Yeah.
Oh, I got to teach you some new stuff then. That'll be good. Maybe I should catch up to you all. Hey guys, I'll try to catch up to you. I'll do my partial fraction stuff real quick. I might get to teach you a couple new things here. We'll see. So,
I got through this part and then I just got a little lost. I think I got
So you
it.
only have 3/4.
Did you? Wait, do I need a number?
so let's see here. -3.
Do I need an answer?
So,
Spell it out.
Minus the other 3/4.
okay.
Wait, where'd you go?
So then -2. So did you guys?
Where's your DX?
I got those.
I'm sorry.
Yeah. No, I'm stuck.
Forgive me.
No. Yep, no, I can say with full
Oh yeah, I know what we're gonna do with this one.
right now. I'm stuck.
This one's not a big stretch.
We did this before.
I don't remember.
So let's see here. 1 over x plus 2 plus -1. So hey, let's just double check ourselves on our partial fraction decomp. Did you all get this?
Yes.
1 over x plus 2. Hey, Logan, Jack, you all agree with that? I just want to make sure we're on the same page.
Yeah.
Okay.
Yeah.
So then did you get, when you did your Antiderivatives, did you get ln of x plus 2 absolute valued minus ln of x plus 3
Plug in.
absolute valued? Evaluator from 1 to b? Okay, so let's see here. This goes,
-1 to B. Wait.
or -1 to b. Yep.
Wait a minute.
Is that a 3?
I lost my -1 from the
It's
get-go.
like a snake.
That's like a squiggly line.
I'm writing fast. That's a 3. Okay, so then let's see here. Limit as b heads towards infinity. This would be ln of b plus 2 minus ln of b plus 3
So it's just ln 4 minus ln 3.
minus, and this would be ln of 1 minus ln of 2.
Oh, I'm kind of stupid.
I'm confused.
Well, hey guys, hey, all of just the random chit chat, that needs to cut right now because a couple of folks have said, I'm confused. So what's your question, Peyton?
Oh, just keep going. I'll figure it out.
I like combined the LNs.
Well, so I think that's going to be a natural thing we'll do for sure. If you guys are okay with this, I'm gonna erase my partial fraction stuff so I can write a little bit larger here for you all.
Well, I like combined them before I started plugging in. Is that bad?
No, I don't think so. So why don't we do that now? I'm fine with that. So we go limit as b. Well, hang on.
Yeah, I feel like it's.
I'll combine on the second, or I'll just do the second ones, right? So like here we get ln of b plus 2 minus ln of b plus 3. And then ln of 1 is? 0. 0 minus ln of 2 is just negative ln of 2, but then we're subtracting it, right? So it's really just plus ln of 2. And maybe this would be where you'd apply your limits, right? So you'd say, all right, as b heads towards infinity, what does the ln of b plus 2 do?
Infinity.
Yeah, so you end up with this infinity minus infinity plus natural log of 2. And this is one of those indeterminate forms that we don't really talk about much in our class, and it's not part of the BC structure. So you don't have to worry about this being on like the AP test, or really even honestly on one of my tests in this particular form. Infinity minus infinity, we really want to say that the answer is 0, don't we? The answer's got to be 0 here. But as it currently stands, we just don't know yet, because infinity doesn't have to follow the properties of real numbers, like 9 minus 9 is 0. Infinity may or may not actually follow that. So what I would do is encourage you to get to a L'Hopital's form that we do know. And that would be recognizing kind of what Julia did early on.
Wait a minute. Do we have to go all the...
Slow your roll.
Hold your horses.
Wow. Or hold your horses. Like, that's very appropriate based on the chapel message. So we would combine our natural logs by quotient, right?
I can do that.
So now what I would do is I would say, well, I'm going to apply this a limit to that fraction. And when I apply the limit as b goes towards infinity to b plus 2, don't I get infinity?
Yes.
And as I do the same thing to the denominator, I get the exact same result. That means that L'Hopital's condition has been met, and I can apply L'Hopital's rule to that b plus 2. Okay, hey guys, the shouting out right now is not going to serve us well. Raise your hand or wait. So does anybody have a question? Forrest.
I didn't get that step. Can you repeat it again? Like how does ln b plus 2 minus ln b plus 3 becomes
Oh, how does this go? This is a log property. So if you have a log of something minus a log of something, if the log bases are the same, you can condense that by dividing the inputs. This is a pre-calc thing. I have never taught this to you because presumably you did well in pre-calc. So I should say presumably you remember pre-calc. I have not directly taught this to you. I'm just an assumption on my part that you've done it before. Other questions on so far what we've done? Logan, Jack, Sam? So far so good? So now I'm going to apply L'Hopital's rule to the whole thing. So to the whole fraction there. So it's going to be now the limit as b approaches infinity. Well, this would be ln, and what's the derivative of the numerator? What's the derivative of b plus 2?
Oh, 1. It's 1 over
It's
1.
1. And what's the derivative of b plus 3? 1. So the truth is, now that we've applied L'Hopital's rule, the limit becomes somewhat inconsequential, right? There's no more b's for us to apply it to. And so we end up with ln of 1 plus ln of 2, therefore giving us a nice, tidy final answer of ln of 2.
That sucked.
That's sick. Like, it's like
That-
so
We're living in a world of suck.
it's kind of crazy that it works.
Logan, I got to say, I completely disagree with you. Like, to me, it's amazing how we can take all these different skills into one question and say, number one, you have the capacity to do all that. Number two, it's amazing how it all works together, and how, as a mathematician, and again, I'm a fan of treating you guys like mathematicians, not like little JV students that are just here to get a grade. I'm here to treat you like varsity mathematicians that are here for learning and understanding versus the, please God, just give me a grade and get me out of here. You probably won't survive too long this year if that's your attitude, just saying. And I think inside of all of you is that mathematician that is seeking understanding and learning. I think it's awesome the way all this can come together. And it took, yes, granted, it took like half your page probably. You had to write fairly small to get it all in there, but I think it's kind of cool. Who in their right mind would have thought, hey, can you imagine if somebody just glanced at this and said, oh, I don't know, I think the answer is roughly ln of 2. Like, no one would have guessed that, right? It's a surprising answer, kind of like pi the other day, right? Unexpected, yeah. It's natural log of 2. Okay, so let's see. I think we've got one more thing here that I feel like I'd like to go over with you.
Very cool.
Tight. Now it's a cool problem.
Now that's really
Now it's a really cool problem.
Good question on
the
that.
answer to that.
Okay, yes, Santi?
When you do the,
0.69.
so when you did the L'Hopital's rule,
Yes.
and it's like the ln
That
of b
doesn't
plus 2 over b plus 3.
Yeah.
Do you do the derivative of just b plus 2, do the derivative of ln of b plus 2?
So the ln, so guys, you should probably hear this. The ln has really nothing to do with the infinity in the top and the infinity in the bottom. The truth is, of course, we're about to do natural log of whatever that is. But because the limit really only applies to that little fraction in there, we can go in and we can doctor it up with L'Hopital's rule as needed, get it where it needs to be, and then do ln of the rest.
So it's as if like the ln is on the outside.
Yeah, totally.
That's why I got a b.
Yeah, so you could say that the limit of ln of something could be rewritten as ln of the limit of that something, if that makes sense. Let's see here. So number
I'm
9.
really excited about this one.
So I think number 9, I think, is worth doing just as kind of a final capper. I think we're done at 10:50. We're done at 10:50, and so this would be a good one to finish on. I put the thoughts on the comparison test and the p-test. I put that at the end there because we don't really have to do that right now. It would be if we had like 10 minutes at the end of a class to talk about those things, we would. But I'm okay if we just kind of left that alone for the moment. That's something we'll definitely pick up when we get to Power Series. So it's not mandatory at all right now. If you're curious about it, come in at lunch or some open period, and I'd be happy to talk to you about it. But number 9 is a good one. And number 9, once again, will allow you to do some awesome combining of skills. Ooh, interesting idea. Yes, ma'am.
Oh, that's fine. Infinity minus infinity. Wait a second. Add a number to the infinity.
I'm just
That's a lot.
not sure how I would take the limit. As
Or is it just one negative?
I'm going to catch up to you.
No, because any other number to the infinity is infinity. Plus it's like really small.
What you got going on?
It's less than 1 over
Plus,
0.
I'm like plugging the negative b in.
You can't put that
I don't think
Because
we're gonna get it.
infinity squared is bigger than.
You know what's crazy? Is it, I think this goes.
I see a L'Hopital.
infinity.
I see a
So I'm just gonna circle this and.
Negative infinity
No,
squared times e to the negative
You got
infinity.
b squared e to
Technically,
the
it's a
negative b
numerical
plus
answer.
2b e to the negative b plus 2e to the negative. Ooh, so we could do 4. Oh, no, because there's a b. Just
So we
kidding.
have, this is all 0, 0.
No, you're trying to combine like terms.
But I call myself because I'm a genius.
Okay, infinity, e to the negative infinity.
Oh, you still need to
Plus.
write
I can't plug
limit
it,
as
can't
b
plug it.
goes to
To
infinity.
infinity.
So I've gotten to a part where I've got my antiderivative up there. I did use integration by parts, the tabular version.
Me too, Logan.
So hey Sam, look at what I've got up on the screen. Are you there?
Yes.
You're not lost there? Meg, question?
Yeah, why do we switch from negative infinity to infinity?
So what I did is I made that a negative b.
Okay.
I think you can handle it either way.
Because negative b equals negative
Right.
infinity.
Got it.
Yeah. I tend to do it this way, but you could do it the other way too. So hopefully we'll see that coming out. So I would apply now the FTC. I'd apply my 2 limits here. So limit is b heads towards infinity. And it's going to be, so when I plug in the 0, won't I essentially get 0 minus 0 plus 2?
Yes.
This last term here, won't it be 2e to the 0?
Yeah.
Does that make sense?
Yeah.
Okay. So that first piece is going to be 2 minus, and then, so I'm going to plug in a negative b. So it's going to be, remembering that a negative times a negative is a positive, wouldn't you get b squared e to the negative b plus 2b e to the negative b? Still with me?
Where did the 2 come from in the beginning?
Because 2
This 2?
is 0.
Oh, that 2, got it.
Yeah. Plus 2e to the negative b. And to me, this is where, if we maybe do one more step, this will make a lot more sense. So limit is b heads towards infinity
Wait a minute, I get it.
of 2 minus, it's going to be b squared over e to the b plus 2b over e to the b plus 2 over e to the b. And now when we try to apply this limit as b heads towards infinity, can you see how the last 3 terms are going to head towards one number?
Oh,
0?
0.
So it ends up just being 2 minus 0, aka 2. So maybe that's a good hint there. When I think whenever like your improper limit is negative infinity, I prefer to make b head towards infinity, make the lower limit negative b. To me, that makes all the little detail arithmetic-y stuff at the end a little bit easier to finish with.
Oh,
So it's
man.
just
So-
2.
So the answer, I think, is just 2. Yes, sir.
Why does that equal 0 for that second term again?
So this comes down to, man, I can't remember. I'm trying to remember when this would have been. So whenever you've got a fraction like this, have we talked about the rankings in here? I can't remember if we have or haven't.
That's insane.
So the numerator is a polynomial, right?
The answer to that is
For all 3 of these fractions, the numerators are all polynomials. So like b to the 2, b to the 1, that kind of thing. The denominators are all exponentials. Exponentials will eventually grow infinitely faster than any polynomial. So as b heads towards infinity, the numerator will eventually be infinitely bigger and growing infinitely faster than the numerator. So you'd be heading towards an overall value of 0. Kind of like the concept of if the numerator is held constant and the denominator gets super huge, you're heading towards 0. It's the same idea. It might be good to go back over the rankings thing again. Santi?
How do you know you didn't lose any signs?
How what?
How do you know you didn't lose any signs?
How do I know I didn't lose any
Yeah,
signs?
'cause I got like a different like positive thing negative.
Well, let's look at your work for sure. Hey, we're good. You guys have a good rest of your
Thank
day.
you very much.
Yep, thank you.
No.
Nope. What do you?
Nice to meet you, Bobby.
I somehow lost it like in these.
Fab.
Let's see
Yeah,
here.
have
What does
fun,
your
Bobby.
derivative look like?
Bobby.
X
Yeah,
Forgot the derivative.
X squared is-
It's a great time.
Should be-
Honestly,
Where is your final like finished derivative?
I mean, sometimes.
I thoroughly enjoy it.
That's what I'm lost a little bit on your,
Yeah.
because I'm guessing you
Lots of
lost a
pretty
sign on
ways
like
here.
maybe like the minus.
This looks the same here. That's what you had.
Okay, yeah. So x squared e to the x minus 2x e to the x plus 2 e to the x. Agreed.
Yeah.
Okay, so then you plugged in.
On right now.
Okay, so you have
He spelled coffee.
0
I'm really
minus
upset about it because this is like
e
favorite
squared e to the negative
wine. Then
b.
Mikey got coffee on it.
It's mine.
It's mine.
Why is this
I've owned it for like the
plus
past
now?
3 months. and-
Because we're going to the next one. Oh, that's where I lost the negative.
Shouldn't this be
Yeah, it should
minus?
It should be minus.
Okay, that's what I'm thinking. Because then you'd have a double. So it ended up being. Yeah. So it ended up being minus, and
yeah,
then
and then end up being minus.
yeah, and then the last one should also end up being
Minus.
minus.
Which this makes this negative.
Does that make
and
more
then that's how you
sense?
can. Okay.
Okay, is that good?
Yeah.
Okay, so just one little sign. But sometimes one little sign makes all the difference.